Hey, if you've ever spent any time with Rockwell PLCs, you have definitely used the MOV instruction. I mean, it's about as fundamental as it gets. But what if I told you its name is, well, basically a lie? Let's dig into what's really going on when you drop that instruction into your logic.
So let's just start with this question right here. What if the instruction we all call move doesn't actually move a single thing? It sounds kind of weird, right? But, getting your head around this is the absolute key to mastering how this command really works and avoiding some major headaches down the line.
And there it is, the big reveal. The MOV instruction isn't a mover at all. It's a copier. It just takes a little snapshot of a value from one spot and pastes a perfect duplicate of it into another. And the most important part, the original data stays right where it was, completely untouched.
So how does this whole copy thing actually happen under the hood? Well, it's a really simple and logical process, but it only kicks off when your run conditions are true. Let's walk through the exact sequence of events.
It's really just a four-step dance. First, obviously, the rung has to be true. As soon as it is, the PLC reads the value from your source tag. Then, it writes an exact copy of that value over to the destination tag. And here's that critical final step again. The source value is left completely unchanged. That right there is the copy, not move, in action. It's simple, for sure, but remembering that is going to save you so much time when you're troubleshooting.
To make this work, the instruction just needs two pieces of information, a source and a destination. The source is where the data is coming from. That could be a constant number you type right in, a value from a sensor, whatever. And the destination is just where you want that copy to end up. You're basically just telling the PLC, hey, see that number over there? Go put a copy of it right here.
Okay, so this is where things get really, really interesting. And honestly, a little dangerous if you're not paying attention. The MOV instruction has this powerful kind of hidden feature. It automatically changes the data type of the value it's copying to fit the destination.
Yeah, as our source material points out, this whole auto-conversion thing is designed to make our lives easier, right? You don't have to waste time manually converting numbers between different formats. But, and this is a huge but, you absolutely have to understand how it's doing that conversion, or you could end up with some wild, unexpected results in your program.
So here's trap number one, rounding. Let's say you're moving a number with a decimal point, that's a real data type, into a tag that can only hold a whole number, an INT. What do you think happens to that decimal part? Well, the MOV instruction is smart enough not to just chop it off. It actually rounds the entire number up or down.
And this is a perfect example. If your source value is 10.7, a real number, and you move it into an int tag, the PLC rounds it up to 11. On the flip side, if the value was, say, 10.4, it would get rounded down to 10. This is a super important detail, especially if you're doing any kind of math with these values.
All right, on to trap number 2, truncation. This is a nasty one. It happens when you try to move a value from a really big data type, like a 32-bit dint, into a much smaller 16-bit int. The little container just can't hold all the data from the big one. For example, if you try to move the number 70,000 from a dint to an int, it comes out the other side as 4,464. Why? Because the PLC just lops off the extra bits it can't fit, and that can completely and unpredictably change your value.
Okay, so if MOV has these, let's call them quirks, with data conversion, is there a better way to do things when you don't want that to happen? You bet there is. And this brings us to a little showdown. MOV versus its cousin, the cop, or copy instruction.
I absolutely love this analogy because it just hits the nail on the head. Think of MOV as this really careful translator. It looks at the value, it sees the destination's data type, and it makes all the necessary conversions. Cop, on the other hand, is like a brute force, high-speed photocopier. It doesn't look, it doesn't care, it doesn't translate, it just makes a perfect, byte-for-byte duplicate as fast as it possibly can.
This table really breaks it all down. MOV is your guy for single values, especially when you need that automatic data conversion. But copy is the champion for everything else. It does an exact byte-for-byte copy with no questions asked, which makes it perfect for copying entire arrays of data at once. And that has a huge impact on performance. MOV is just naturally slower because it has to stop and check data types. Copy just goes. It's way, way faster, especially when you're dealing with big blocks of data.
All right, so theory is great and all, but where would you actually use this stuff in a real-world machine or process? Let's take a look at some of the most common applications for the good old MOV instruction.
Yeah, these are some of the classics.
You can use MOV to take a value from an HMI screen and pop it into a timer's preset. Or you can reset a counter just by moving a 0 into its accumulator. But a really clever use is to unlatch a coil. An OTL instruction, an output latch, will turn an output on and keep it on forever. By MOVing a 0 into that output's tag, you can reliably force it off from somewhere else in your code.
And our source material gives us a great real-world example of this. In a set of machines they call the footprints presses, a move instruction is used for that exact purpose, to reliably turn off a specific latched output. It's not just a textbook trick, it's a super practical and common technique out on the plant floor.
So let's wrap this all up. What are the absolute must-remember points here? Number 1, MOV is a copycat, not a mover. The source is always safe. Number 2, watch out for that automatic data type conversion. It can be your best friend or your worst enemy. Number 3, MOV is your go-to for single values, especially if you need to change the type. And finally, number 4, when you need speed and an exact copy of an array, you call in the cop instruction.
And that kind of brings us to our final thought for today. Now that you really get the difference between MOV and cop, I want you to think about your own programs. Where are you maybe using a whole bunch of MOV instructions to copy array data, one element at a time? Where could a single, much faster cop instruction make your logic cleaner, faster, and more efficient? It's a small change, but it can make a really big difference. Thanks for tuning in.